So just as a brief overview of what to expect during this presentation, the first part will discuss some of the design choices we made, as well as some of the tools we used in order to implement various features of our application. This will include talking about the MERN stack, using Figma to create mockups of our pages, and using Auth0 to provide authentication for our app. The second part will discuss some of the challenges we faced during the project, including implementing the web extension feature of our app, as well as continuous integration and deployment. I will now pass it to Riemel to start talking about the MERN stack.
For our design choices, we focused on two main options: the mean stack, which is MongoDB, Express.js, AngularJS, and Node.js, and the MERN stack, which is basically the same thing, except we substitute AngularJS with React.js. We chose to use the MERN stack in our application for a few reasons. One of them being that most of our team members have prior experience with using React.js. Also, React.js is simpler to learn because of its straightforward design, as well as it having numerous popular tutorial videos and easy to understand documents readily available online. Another reason we favored the MERN stack over the mean stack is that React.js outperforms AngularJS, since React.js applications make use of a virtual DOM, which allows developers to make changes without having to rewrite the full HTML document. It also ensures for a speedier performance by rendering updates faster. We will now move on to the next topic on design choice and tools used.
One tool that we use for helping us design our user interface is Figma. Figma is a browser-based software application, and it provides a real-time collaboration tool for creating UI prototype. So it uses vector graphics drawing that is user-friendly and as well as provides the CSS code generation. So we wanted to make our app lightweight, so it will not depend on third-party UI libraries. It also has a community that can share thousands of pre-designed templates, icons, UI kits, so that we are not reinventing the wheel. Some of the usage with this application include exporting icons, generating CSS code. So the transition between design to implementation is seamless due to the fact that it gives us the CSS code right off the bat. And it makes it easy to create CSV icons and get its code and import to our project. This significantly reduces our trial and error method with CSS since we have a single source of truth. We also use it for pre-development discussion for component breakdown and asynchronous discussion too. So we directly comment on designs, and this will allow us to have faster feedback and discuss on how to break out a design in multiple bite-sized components. Here are the mockups that we have came up so far at this stage of our project. So here are our workspace dashboard, workspace settings pop-up, sidebar, Chrome extension dropdown, and text box pop-ups. I'm now going to pass it on to Faith to talk about Auth0.
In our application, we are using Auth0, which is a platform that provides authentication services for web applications. We use this for our account creation feature, and it manages and stores the necessary information about our site's users. It provides us functions for signing up or logging in, and it simplifies things for us so that we don't have to handle saving and securing passwords in our own database, which definitely saved us a bunch of development time. Instead, our own user objects only contain the user's Auth0 ID, as well as other information that is needed for our application. You can see an example user object here on the bottom right, where it contains an attribute named Auth0 ID. And if we ever need other attributes or information about the current user that we don't have in our object, we can easily access this by importing the Auth0 library within our own code. Another cool thing about Auth0 is that it provides us with the UI for signing up and logging in. We could easily customize this to our needs, so here we change some of the colors of the background and the buttons, We also added our own logo. I'll now pass it up to Josh, who's going to talk about our web extension.
A major component of our application is the Chrome extension. Going into this project, none of us had ever made a Chrome extension, but knew it was vital for the functionality of our product. Luckily for us, the process of making one doesn't have a very steep learning curve. When creating a Chrome extension, the most integral piece is the manifest file. It's a JSON file which describes all the information for the extension. It takes in properties such as the name of the extension, its description, scripts that will be used to handle the functionality, and others like the required permissions for the scripts. A few examples of required permissions are the notifications, so you can notify the user of any information you'd like to give them, the tabs permission, which allows you to create new tabs, which we use for easy access to our main page, and context menus, which in our case allows us to add our own options to the right-click menu to save text to our workspace. Adding functionality to the extension is done using JavaScript and the Chrome API. Calls can be made to the Chrome API to allow you to hook into the functionality of the browser. The Chrome developer page is a great reference for documentation of the things you can do, and in addition there are plenty of tutorials online to get you started. Finally, to load the extension, all you need to do is enable developer mode in the Chrome extensions page, click the Load Unpacked button, and select the folder your Chrome extension is located in. One of the problems we came across during the development of the Chrome extension was dealing with the unexpected incompatibility caused by the manifest version. The manifest version is essentially which version of the Chrome API you're using. Initially, our version was set to be version 2. However, at the time we didn't realize that Google had stopped supporting the manifest version 2 back in January. This had no issues up until the week that Sprint 2 is due. Google prohibited extensions with version 2, causing our extension not to run at all. This caused mass panic among the group, along with a few restless nights and getting caught up in a few rabbit holes while trying to update our code base to match the new manifest version 3. Ultimately, however, with the hard work of the team, we managed to pull through to a solution. Overall, we learned to make sure to read documentation very carefully going forward, and to try our best to stay calm and collected when things don't go as expected.
With the current developments of our project, we have implemented the Chrome web extension to connect to the workspace and text database. In doing so, we ran into some problems with the REST API. We had two main options where we can properly implement the REST API, the Fetch and Axios APIs. In our web application, we are currently using the Axios library to make requests to the database, but we could not apply the same method for our Chrome web extension build. After numerous research, we found out that external modules like Axios would need to be bundled into the Chrome web extension in order for it to work as we intended. We can use a bundler like Webpack in order to do this, but there's a decent amount of work and configuration needed to get it up and running, so we saved ourselves the hassle. It was recommended to use the Fetch API as an alternative, as it is already freely available in Chrome extensions and works in every similar ways to Axios.
We had originally planned to follow the Jenkins tutorial to set up our continuous integration, but we found that there is quite a steep learning curve and we kept running into different issues as we were setting it up. So after doing some research, we found an easier way to set up continuous integration through GitHub Actions. When setting it up, it automatically creates a YAML file where the workflow is set to run on every push to or pull request for the main branch. To the left here is an example of our YAML file for our front-end tests. Here we have the push and pull request details and the branches that we want the workflow to run on. And here are the steps which installs the dependencies and then runs the front-end tests. We also decided to split up our workflows into 3, where we have one for the auto build, front-end tests, and back-end tests. Doing this helps us determine and investigate failures a little easier. I will now pass it off to Iman, who's going to talk about our continuous deployment.
I'll now conclude by talking briefly about continuous deployment. It was a little bit tricky finding a way to get the app to build through Docker using separate images for our front end and back end. Eventually, I managed to find a tutorial that uses what is called a Docker Compose YAML file. So what the Docker Compose does is it takes the images for our front end and back end, and then it combines them into a single service, which allows you to start and stop the entire app using a single command. Then using GitHub Actions, you can build the front end and backend images and then upload them to Docker whenever we need to. That'll be it for our presentation. Thank you everybody for listening, and we are now open to any questions that you may have about our project.